let's see, all we did is recopied everything that wasn't underlined or identified as spectators. So 3 CrO4 negative 2 aqueous, good. 2 Al plus 3, good, aqueous. Al2 CrO4 parentheses 3 solid, good. Looks good to me. Now you can always check to see that it's balanced. I have 3 CrO4s, I have 3 CrO4s. I have 2 Als, I have 2 Als. I have 6 negative charges and 6 positive charges. So this side's 0. That side has no charge, it's 0. Good there. Let's look at this. Everybody good here, by the way? So next we have on our worksheet that was up on eBackpack. 1, all right. Okay, so that's not here. Okay, Jarrell. What's the first thing you should do with any of these reactions?
I have no idea.
You have no idea, I don't accept that as an answer. So did you get notes on single replacement reaction yesterday? You didn't get it. Why not? You didn't get it today. Okay, that makes no sense, but okay. All right. Gary, what are you going to do first for any of these reactions?
I don't know how to say it, but can I show you my work?
Yeah, okay, so what are you doing?
I moved the N to Ag.
Okay, so you're going to check and see if zinc can replace silver.
Yes, I did check, and it gave me the result. The Zn is higher than, on the list, is higher than Ag,
Perfect.
which works.
Perfect.
Yeah.
Okay, that's exactly what I wanted to hear. Gary said, look, I want to know if I even have to do anything, right? Because if I don't have to do anything, I don't want to do nothing, right? If I can be lazy, I'm going to be lazy. So what do? We look and see, can the replacing metal actually do the replacing? So can the lone metal replace the one that's in the compound? And we look at our list, and zinc is higher than silver. Remember, silver and gold and them are way at the bottom, right? Zinc's higher up, so this can occur. Now, if it were the other way around, what would you do? Straight no reaction. Okay, but we can't do that. Okay, so now that we got a reaction, Bo, what are you going to do next? Yep, so you get our charges up there. Good. Do you understand why though?
Yeah, now I put blocks in my head.
No, it just happens to be +1 because it has a +1 for an oxidation state.
You just want me to do that, or you want me to?
That's good enough for now. Okay. So that's a +1 there. Okay, now I'm going to point out. Does anybody know the one problem that he has? What is it, Garrett?
Sulfur.
No.
Zinc should be +2.
Zinc should be +2. Yeah. There's another problem there. Okay, we'll go up there and I'll show you. Not everybody knows this. All right. Yes, that should be. Oops, this is +2. That's +2, Bo. Okay.
Oh, yeah.
All right. So this is good, but we don't need the charge for this. Why not? What state is it going to be?
Solid.
Solid. So we could go right to this. Okay, so I'm gonna write down my charges. Now, if I'm doing a double replacement, I'm gonna have 4 charges, because everything's gonna be dissolved in solution. But this is more like a thing like this. That AgNO3 is actually this. Okay. But instead of putting copper in there, I'm putting zinc in there. What the heck does that say? Hockey?
Yeah.
All right, so time is getting to be an issue, so let's get this done. So let's just get this done. Okay. 'Cause we gotta practice. You guys got through the other one pretty good today. Let's move along with this. Okay, so when I crisscross this, what do I get? Go ahead. Anybody? Zn. NO3. Parentheses. 2. Take a wild guess as to what state that is. Aqueous. Now, if you didn't know if it was aqueous, how could you check to see if it was or wasn't? What tells you something's soluble or not?
Solubility.
You got solubility rules. And if you looked up the rule for nitrate, it'd say all forms soluble, no mention of zinc. Okay. Now, am I balanced? No. So what's out of balance right now? NO3, so I'm going to put a 2 here, which forces me to put a 2 over here. Okay. Next step is to take everything that is aqueous and separate it out. Now, we didn't look up the charge for silver yet. Well, at least we didn't need to. But this would separate into silvers and NO3s. NO3s we already looked up. Silver, I go to my periodic table, and I see that silver has an oxidation state of 1. So that means it's going to be a +1. I could also cheat. How could I also cheat and get that? It's on your activity series is +1 as well. These are both aqueous. And coefficients, I have 2 of each. What do I do with zinc? Leave it the same, just bring it down. Zn solid. What do I do with 2 silver? Leave it. And then I pull this apart, which I already wrote the stuff down for that. So it turns into Zn plus 2 and NO3 minus. There's 1 of these, there's 2 of these, and they're both aqueous. Now I do what? Spectators, and I go to spectator here. And here, single replacements usually have 1 spectator. And then I copy down what I got left. 2Ag plus aqueous plus Zn solid yields 2Ag, this time with no charge, plus Zn plus 2 aqueous. Some of you guys starting to catch on to this. Can I tell you probably the most crucial thing? Is this step right here of balance, getting your balanced equation, because everything follows from that. Yep, John?
If we did put the charge with AG on above it, that wouldn't be wrong, would it? It just
As long as you didn't put it here, because it's not charged. Charge means it's dissolved.